This is Honors Algebra 2 Pre-Calculus. We're doing section 10.3 in Pre-Calc, which is ellipses. The definition of ellipse on page 716 in your textbook says that an ellipse is the set of all points x, y in a plane, such that the sum of their distances from two fixed points, which we call foci, that's the plural of focus, is constant. So when I'm in class, I can do like a fun demonstration of doing this where I give a piece of string to some people and then we kind of walk around, but I don't really get to do that here and it doesn't work the same way. So, all right, so here's the idea. I have 2 points, right, that I'm going to call my foci, so F1, F2, okay? And those are fixed. Right, and then let's say I have a certain amount of, and again, I'm going to use like a busted old phone cord here, so this is not even particularly impressive, but let's say I have this little piece of phone cord, right, and I have a certain length of that phone cord, right, that I'm going to use. So if I wanted to find all of the points that were a fixed distance, like let's say from this amount, right, from this finger to this finger, from those points, like the sum of the distances, what would happen is if I try my best to fix those, and it's going to be difficult to do, but I'm trying, right? So I'm going to try and fix those 2 spots. So I have this much distance. So if you look, what happens as I go around is it's going to start to make this like weird oval egg shape. And again, it would work better if I weren't using a busted old phone cord. But if I did the same thing on the bottom half, it would come out to look like this essentially. And again, really terrible job because busted phone cord. But you'll see that it kind of comes out as an oval, right? So this is an ellipse. And the idea is that if I pick any point on that ellipse, which I'm just going to show you in red real quick, I pick some random point and I measure this distance plus this distance, I get a number. If I picked any other random point and measured this distance plus this distance, I get the same number. So whatever this distance is plus this distance, if we called like this one D1 and D2, right? D1 plus D2 is going to be some constant, right? So where D1 is the distance to focus 1 and D2 is the distance to focus 2. So even though this D1 and D2 are different, if I add them, it's still going to give me the same constant. And like here, you might say, oh, but on these ends where it's really close, well, that's because this distance is really short, but this distance would be really long, right? And so they're going to add up to some constant. That's what an ellipse looks like. So there are a couple, we're going to learn some terminology about an ellipse, but I think it's a little bit easier if we can kind of see what it looks like, right? Now, you might have an ellipse that is, you might have an ellipse that is long and skinny, sort of like the bad example I drew, right? You might have an example that is tall and thin, right, if the foci go this way, right? You might have an example that looks a lot like a circle because the closer the foci get together, the more circular it is, right? So you might have an example that where the foci are 2 very close together points, and then you're going to have an ellipse that fundamentally looks darn close to a circle, and I did a bad job drawing it, but you get the idea. So we're going to do some vocab about these things. So when we talk about an ellipse, we talk about a major and a minor axis. So let's walk through some vocab, and then we'll start to talk about some other things. Okay, so I'm going to draw a sample of an ellipse, right? And I'll draw one that's going in this direction, right, where my foci are on a horizontal line, right? And I'll draw one that goes this way, where my foci are on a vertical line, and we're going to talk about how these work. Okay, so in an ellipse, the longer direction, right, the longer direction of the ellipse is called the major axis. So this thing right here, okay, these things in blue, the longer direction, right, is called the major axis. So I'm going to write that in blue. So the major axis, okay, and that major axis is going to include 3 important points. It includes both foci, right, so that's 2 points, and it includes the center of the ellipse. So I'm going to put the center in green, right? The center is halfway between the 2 foci on the major axis. So it includes both of the foci and also the center, right? Going in the other direction, but including the center, right? Oh, and actually, I'll add one more thing it includes. Sorry, take that back. It also includes these things that we call vertices. So the ends of the major axis are vertices, right? So these little things were foci. So if I want to call them F1 and F2, right, and V1 and V2, right, I could call this F1 and V1 and F2 and V2, right? So those are, so it includes the foci and the center, and on the ends, the vertices, right? So vertices is plural of vertex, right? So the vertices, right? So the major axis has a bunch of stuff. Going in the other direction, we have what we call the minor axis. So going perpendicular to the major axis and also through the center is what we call the minor axis. So the minor axis, which is perpendicular to the major axis, so if the major axis is horizontal, the minor axis is vertical and vice versa, okay, includes the center, right, because it also goes through the center, right, and then, and this is a Hoganism, I can spell my own name, Hoganism, the non-vertices. So we're gonna, this is not a real thing, right? It's not a thing, but when you're graphing these, I like to call these the NVs, because that way I know where they appear on the graph. And we're going to talk today about how to graph them and all this other stuff, but it's helpful to know the basic terms. So again, NVs are a Hoganism, but you'll notice that we have a major axis, which is the longer direction. We have a minor axis that is the shorter direction. Every ellipse has a longer and a shorter axis because otherwise it would be a circle. If the two axes were the same, it's not an ellipse, it's a circle, and then it's a whole different set of problems. So when we talk about this, right, we're going to talk a little bit about what numbers can go on this. But so as we talk about this in the next video, what we're going to talk about is letters A, B, and C, okay? A is going to represent the distance from the center to a vertex, right? So that's A, right? So what that means is that the major axis, right, because this whole thing from the center to a vertex and from the center to a vertex is A, right? So what that means is that the major axis is 2A units long, right? So whichever the major axis, whichever one the longer axis is 2A, right? My minor axis, the measurement from here to here, from the center to the not vertices, which again, they don't have a name, but that's weird, so I gave them a name, is called B. So again, this shorter measurement is B and another B. So the length of the minor axis is 2B, right? Or not to be if you want to make a Hamlet joke. So 2B, right? And the major axis had a length of 2A, right? So 2A, just so we know, right? And then the last thing that we're going to talk about, and we'll do this on the next video, is that this measurement from the focus to the center is called the letter C. So these are both C's, right? Same thing here. The center to the focus would be C. The center to the focus would be C. So we're going to talk about this in the next video. We're going to talk about how to graph these and how to write the equations, but it's helpful to kind of know the terminology before I throw the A's, B's, and C's and other stuff in there.